Okay, so Jeremy, I've done a few comparisons across different things with some of Databricks' competitors. Uh, Recently, I had done some performance comparisons. I'm curious, how important are performance comparisons against competitors to you?
Yeah, I guess are you kind of alluding to benchmarks, kind of the standard
Yes. Yeah.
TPC? Yeah,
Hey, how do we perform doing this task and this task?
yeah. So it's kind of the debate I think amongst all debates in performance is do you use standard benchmarks or other tools to compare against competitors? I kind of have a belief that I'm not as indexed as high on benchmarks. I think that look, there's many benchmarks out there and they all do serve a base purpose. We do really like the TPCDS benchmark just because it's such representative of a broader workload. It's got 99 queries versus so TPCH has I think 21, 22. Um, but we really go heavy on just like what are our actual customer workloads doing and how are they performing? Are they getting better or worse over time? And so we actually introduced this thing called Performance Index, where that we worked with the data science team over this past, a little bit over a year to look at queries over the last 2 years, a little bit over 2 years. And we basically looked to see like, okay, if queries of similar size, similar shape, similar, functions, how are they performing over time? And so we've gone really heavy this year in figuring out how to make that measurement, how to make it accurate, how to get broad coverage, and then how to like dissect and say like, okay, this area is doing better, this area is doing worse. Like, what do we need to focus on, and what do we need to improve on?
Awesome. What have those results looked like thus far that you can share?
Yeah, so we recently did a blog on this, but we published that we're 77% faster. DB is 77% faster than it was when it originally launched in, I believe, April 2022. So quite a bit faster. I think if you do the math, it comes out to roughly 4x. In addition to that, what we are doing now is we've actually been able to break these workloads apart and basically like, okay, this is what a BI workload is, this is what an ETL workload is. And for BI, we're seeing that's like 14% faster. I think exploratory workloads were like 13% faster if I remember correctly, and then ETL was roughly 9% faster. And that's just within since Data and I Summit. So that's not like they improved 70% over 2 years, but in the last 4 months, 5 months, they're you know 14% faster in some cases. So we're just working on making these things faster and more consistent.
Follow on to that, but why would you make things better when you realistically, if you don't, customers are spending more money on compute?
Yeah, well, I mean, there's a lot of options in the market, so we want to lead here. We want to people have choices, and we've embraced kind of the open model, right? Like this is your data, you can take it wherever you want to. We have launched many features to allow customers to take their data wherever they want to. You would choose which engine they want. So I think Databricks just as a whole has embraced that model and said, hey, we're just going to be the best here, and we're going to figure out how to lead in performance, lead in cost, and we make efforts to do that.
So Jeremy, so part of what you do with performance is help improve things on the storage side, help improve things on the compute side, which really are the two elements behind, for the most part, Databricks, right? So with that said, let's start with storage, which one of the things that I like to say about storage is everyone likes to say, oh, storage is cheap. Storage is cheap. But those costs rack up real quick over time, especially if there's a lot of bad practices around storage. So I'm curious, what are some of the advice that you would give to make the most of your storage and performance?
Yeah, so good question. So for storage, we have kind of I think three main best practices that we encourage people to use. The first one is enable liquid clustering. Liquid clustering has made a lot of progress over the last, I guess, is it year and a half. There was some limitations earlier on about like table size. that those limitations are gone. We can support much higher size limits than before. Next one is using managed tables and managed tables with predictive optimization. Predictive optimization does so many cool things now. They just released auto stats into predictive optimization, which basically means that we run vacuum automatically. We run optimize automatically. And then once we run optimize, the reason why that, has so many great benefits is because it will actually get the stats for your table and then pass that on to the query optimizer when, your queries are coming through. So what ends up happening is your queries are faster, you've run vacuum, your data is cheaper, it's more clean, it's more organized. You just kind of get all the good benefits just by doing these kind of 3 simple things. And I guess I'll add one more, and that is try to be on the latest DBR. If you're using kind of the older DBRs, you're not going to be able to use all of the great performance features that are available today.
For the last technical downtime, you want to explain why the Databricks runtime, which is tied directly to the compute side, why that is relevant to this?
Yeah, so we released. So if you think about DBR, it's basically like an operating system, like say Windows. I forget, Windows 10, Windows 8, whatever it is. It's you're going through iterations of a new operating system, and what the new DBRs have are more features that can take advantage of other features. For example, so for example, like in DBR 15.4, you get the best performance in clustering on write. So if you're before that and you see that clustering is slower, you're not, it's because you're not using the latest software. And so we definitely encourage use the latest DBR as much as possible. You'll get the best results for it.
Awesome. Now that's just to nitpick a little bit on that. That's for like the classic compute. How does it work for the SQL serverless? How is versioning? Should I, as an end customer, care about, or even try to understand what version is happening under the hood here?
Yeah. No, great question. SQL is, from the end user's perspective, it's versionless. We always keep it updated to the latest DBR. All the latest features and tools are there. And so, out of the box, it just works the way it's supposed to.
Awesome. Okay. And that same principle for SQL serverless would apply to serverless. So.
Yes, exactly. All-purpose serverless.
Yes. Yep.
Yep, exactly.
So I'm a big fan of using SQL serverless as well as the new serverless, even though in my experience it's still a little bit more costly than SQL serverless when running SQL queries. But that said, going back to SQL serverless, what would you say are what's the best advice you can give customers, especially when they're trying to understand like what t-shirt size should I use for my compute?
Yeah, great question. So t-shirt size, there's kind of 2 things you can do in SQL, right? You can use different t-shirt sizes. You can go up or down, and you can increase your max clusters and increase your min clusters. That's pretty much the only knobs that you have to worry about with configuration. Other than that, any other knob that's available, current channel preview, just don't even touch it. It's for the very rare cases. So for right sizing, the answer is it's actually probably more simple than I think most people interpret it as. So if you want more concurrency, if you want to run more queries, more users at a time, you just increase the max clusters. You don't increase t-shirt size at all. T-shirt size is not really the way to increase concurrency count. It's more just you get more clusters, you get more drivers when you do that. And now you have more drivers, more clusters, you can kind of scale to whatever you need. And we allow you to go up to 40. So it can be very concurrent. I think I've seen, some of the tests that I've done personally, getting up to maybe 700 or so queries per second. So it's very performant when you want it to be. And I think that was probably a year ago. Now for t-shirt size, this one's it's slightly harder, but it's if you kind of make a general, some generalizations about it, it's actually kind of easy. And what that means is that if you take a query and you it runs in 10 seconds, and you increase the t-shirt size up from, say, a small to a medium. If that query size does not, or if the query speed doesn't get better, then it does no good to have those extra parallelization inside of that cluster. So, it's really that simple. The only reason that you want a t-shirt size to increase is because you can make your query more parallel, and you can, decrease the latency. If you realize that, hey, in the opposite direction, this actually isn't getting any faster, and you try to lower it from, like, say, a small to an extra small, and the size doesn't, or the latency doesn't change, that's also, the right way to think about it. Is you're just looking at the high level metrics. You're trying to say, does the query get faster or not? If it doesn't, you don't need to go any higher. If you want to save money, try to go down. If it can go down and you don't see any sort of latency problems, it wasn't doing you any good anyway.
What would you say is the biggest mistake? And so taking the flip side, what do you think is the biggest mistake that you see customers do that can lead to very expensive, I would say, compute choices?
I actually think it's setting minimum clusters. I think it's very rare that you need to set minimum clusters. It's kind of an edge case. Max clusters is typically going to get you what you need. And I'm referring to serverless, right? Because serverless can scale up so quickly now that it's very rare that you would need to have, minimum of 5 clusters or 10 clusters. We can grab the compute within a matter of seconds and start getting queries onto it very quickly. So I just think that, you're probably not doing yourself any favors by setting min clusters high, when it's can just grab the clusters quickly.
Yeah. Again, for clarity, this is within the context of SQL serverless warehouses.
Well, I guess, what is your take on things? Like, what is your take on the state of the warehousing space, the data space, just high level?
I would say that I'm glad to see that the overall benchmark wars have kind of died down a little bit. So it's kind of nice to see. Obviously, there's still some comments, managed Spark SaaS, but it seems a little bit less crazy than it used to be. Overall, honestly, I'm very impressed with how SQL serverless warehouses have improved over time, because I have been personally checking that performance over a period of time. So it's nice to see them improve. I had recently done that one comparison that I have on my LinkedIn between Databricks and Snowflake with a one big table example, taking data sets in like the low billions to up to 180 billion rows. And I was actually to be honest, I was surprised that Databricks won in the lower volume category. Now, they won fractionally, not enough to say, oh yeah, we should pick this over Databricks or Snowflake, but it still beat Snowflake in that one test. So that was surprising. In the larger scale ones, it did beat Snowflake, which I expected that. But again, that was a unoptimized, nothing optimized, anything like that. It was just dump the table in, run those queries, and it performed well. So I'm excited just to see what comes in the future. But at the end of the day, performance, as long as you remain within a competitive distance to your customers, at the end of the day, what's going to trump everything is going to be the developer experience. And I think for Databricks' biggest pro is that it has that warehousing capability, but on top of that, it has all this other tools bundled together. And, you have dashboards, and now you have AI, you have all this fun stuff, and Databricks doesn't just close itself up to say, hey, well, we have our own built-in features, so that's all you're stuck with. They do open it up so people can use Sigma. They can use other tools as well. So it's kind of nice to see Databricks building both internally as well as enabling others to come and say, hey, you want to do something better than we do? come do it. Just use our compute, and we're happy with you. So it's kind of nice to see that. And to more to that, like Steve Sobel told, who runs the venture, one of the venture branches within Databricks, told me at the end of the day, he's like, we want customers to be happy on our platform. So if that means our tools are just doing the trick, then awesome. If that means other tools are doing the trick, customers are using us, that's awesome too. So
yeah, no, 100%.